Hi guys, welcome back. The next part of our Physics 145 is the prefixes. Well, sorry to tell you that prefixes you have to memorize, okay? So prefixes, what is prefixes for? Well, prefixes is a convenient way to let people know that a big number or a very tiny number by using some symbol, okay? But of course, some of the prefixes are commonly used in our daily life without we realizing it. For example, kilogram. The word kilo is a prefix. Okay? Something else like in a split second. The word split second, actually we can use it like a millisecond. So the split is not a proper prefixes, but in physics, when we analyze the word used, split second actually means a very short time. So that short time you can use like millisecond, microsecond if you want, just to represent the word split. Okay, but when you use split second, everyone will know what you're talking about. But if you go and tell a 90 years old non-scientist or not educated old lady, you're going to go there, go to her house to help her out in a split second, of course you understand. But if you say I will reach your house in 1 nanoseconds time, by the time you reach there, you're gonna dump out already, okay? Because you don't understand what you're talking about, maybe. But if she or he is educated, well, the words will carry some meaning to them, right? So our prefixes, there are so many, altogether 24, okay? But you only need to know like about 18 or 12 of them only. So we have this. I'm going to do it in a table form. So these are the name of prefix, okay? Name of prefix, and then this is the power of the prefix, or the symbol, and then the power of the prefix, okay? And then that one we continue on later. Now the first one that we have is, in your case you need to know, is giga, okay? Giga, and the symbol will be big capital letter G, and the power means 10 times something. This one is 10 times power 9, okay, 10 times power 9. And then below that is mega, okay, mega. So it is m 10 to the power 6, and then after mega, below mega you have kilo, small k, 10 to the power 3. This is a very common one we talk about, okay? So the next one after kilo, we have centi. The very common one is centi. So C, this is 10 to the power negative 2. And then you have milli, okay? Milli, small m, 10 to the power negative 3, okay? And then you have micro, okay? Micro, we have symbol mu, and it is 10 to the power negative 6. And then below that you have nano, okay, nano, small n, and then it is 10 to the power negative 9. And then after that you have pico, okay, pico is p, 10 to the power negative 12. Of course below that we still have, okay, we can extend that one. Okay, I think it's enough. So after pico we have femto, F, and this is 10 to the power minus 15. And the next one is atto, A, 10 to the power negative 18. So that one is the one that you need to know, from very big until very small. There are actually more. After giga we still have esa, peta, and so on. This one after atto we still have. So I'll leave that one as a assignment. Okay, I will leave that one as a assignment. Alright. So now, the purpose of all these things will be to reduce the amount of number used to tell a story. For example, if you talk about the mass of a mountain, for example, the mass of a mountain, well, the mass of the mountain, these are examples. So number one, the mass of mountain M is equal to, let's say, 27 or maybe like 200,000,000 kilogram, okay, kilogram, or we just put it as gram, okay, this one as a gram. Now, this one is going to tell people every time people ask a question, for example, tourists, how massive are those things? You keep saying the same number here. After a few months you work there, I think you will quit already. Okay. So the easier way is we look at how many zero we have. For in this case we have 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 9. Look at the power that is referred to 9 is 10 to the power 9. So that means all this zero here can be replaced by big G. So we have mass now is equal to 2 GG, 2 gigagram. Okay, 2 gigagram. So these are just one of the examples for huge number. Okay, for huge number. And then for small number, for example, the mass or the size of bacteria. Okay, the size of bacteria means let's say diameter. Okay, the diameter of bacteria. Well, the diameter of bacteria, for example, use the symbol D is 0.0000005 meter. All right, 0.00005 meter. Okay, so instead of using this number, which has so many zero to pronounce, you can actually change it to using prefix to make our life easier. So for example, this one is, you look at how many zero here, 1, 2, 3, 4, 5, 6, 6 zero. But because it is smaller than 1, we look for the negative 6. So the negative 6 is here, micro. So that means this diameter is going to be 5 micrometer. Okay. So normally in biology, they call it 5 micron. Okay. So this is equivalent to 5 micron. Well, that 5 micron refer to 5 micrometer. Okay, 5 micron. Alright. So these are example of the usage of prefix and prefixes, okay, using all those symbols. Alright. So your assignment will be this. This is your assignment 1. Okay. Find the complete list of the prefixes. Find the complete list of the prefixes. So other than this, so you need to find out in internet, Google them, and then find out other than 10 to the power 9, what else do we have? Okay, just to let you know, the highest power is 10 to the power 24, and the smallest one here is 10 to the power negative 24. So they have some very unusual name, like Yocto and so on. Okay, let's find out. So this one is your assignment number 1. Okay, that is the assignment. All right. All right. Each of you do. Each of you do, no group work here yet. Okay? No, because this is something very easy. Alright? Okay, that is prefix. Now the next one is a conversion of units. Okay? Conversion of units. Because sometimes we need some other units to suit some other situation. Sometimes when you study chemistry, you will know this. In chemistry, we normally use the amount of metal in gram. Very small amount in the test tube because the test tube is very small. But if we use the way we do in physics, you're talking about kilogram, meter, and so on. And not going to mix up chemical by how many kilogram. Not many chemistry lecturer will still alive after the experiment because the exothermic will become so extreme that it might cause explosion like a Beirut recently. Okay, so it's going to be high risk. So that's why we use a small amount. But in factory processes, those are under extreme measure, extreme control, safety control. Then they are allowed to do so. In a school, I don't think in university, in the school, in the research lab, you are allowed to use amount in kilogram. Can you imagine in your school you put one whole piece of natrium in water, they're already hissing, okay, with a lot of gas and flame. Imagine if you put 1 kilogram of natrium or sodium in water, you won't be here to tell the story about what happened next, because people is going to tell the story about you. You are dead. Alright, it's very dangerous. Alright, so conversion unit is used when you need some other units, but it carry the same meaning. Example is when you are asked about density of object. In physics, we normally have 2 units for density. One is kilogram per cubic meter. That's number 1. Number 2 is gram per cubic centimeter. So you should know how to change in between them from one to the next and vice versa. Alright. So I give you some simple example. Conversion unit, we start with example because I don't know how to give you theory on that. With example, you know the procedure, then it can be found. So example number 1, I call it. So this example number 1, let's say you want to convert meter square area. Okay, area which is A is let's say 12 meter square. Okay, now I want you to change the unit. Change the unit to centimeter square. Okay, change the unit to centimeter square. Alright, so that is how we do it. First, we write down the whole thing. A is equal to 12 meter square. Now remember, how do you tell people about the size of the quantity? This is a quantity, this is a magnitude, and this is a unit, right? 2 things you need. So we separate them now. 12 and meter square. So number, we leave it alone, don't do any changes. And then meter, you change to centimeter. Now, meter change to centimeter is 100 cm. So now our meter here is going to be 100 centimeter, but don't forget there is a square, you see? This whole thing here is 1 meter, so square. So now your m disappear, now leaving with this one only. So now I have 12 multiplied by 100 square and centimeter square. Because it is in bracket, the number and the unit will be square. So now you already reach the conversion unit. So the rest now is what? It's just 1200 centimeter square. Alright, so you can leave your answer like that, or you can change it to standard form. Okay, so in our standard form, that will be 1.2 times 10 to the power 5 centimeter. You should have learned this one already long time ago if you still remember. Alright, so these are example which is actually very easy, from big unit to smaller unit. Now next one, we do the opposite. Okay, we do the opposite. For example, now volume. Okay, volume. This is example 2. So our volume, let's say V is equal to 2,750 millimeter cube. Okay, cubic millimeter. Now convert to meter square. Convert to meter square. So how? So same thing. Okay, you use the same procedure, same method. So we have V is equal to 2750 millimeter cube. We separate them out. Okay, we separate them out. So now we have numbers and units. So our units here, no changes. Number no changes, but unit we change. We look at this millimeter. The meter is already there. You just need to change the meter only. So this one is meter cube. Okay, meter cube. So our milli is referring to this one. Milli is 10 to the power negative 3. So you convert that one to 10 to the power negative 3. Negative 3, and then meter no changes, and then power 3. You see? The power is both of them. so it will be in the outside the bracket. So now your milli, you change the power of the milli is 10 to the power negative 3, and the unit meter stay. So now we take it out. 2750 times 10 to the power negative 3. Don't forget the bracket, power 3, and then you have meter power 3. And then the next thing is just combine the number. So 2750 times 10 to the power, this one negative 3, power 3, negative 9 cubic meter. But this is not a good standard format. So you change it to 2.750 times 1000 times 10 to the power negative 9 cubic meter. So finally, you combine this and this. This is 10 to the power 3. 10 to the power 3 and 10 to the power negative 9, you get 10 to the power negative 6. 2.750, 10 to the power negative 6 cubic meter. Alright, so that is how we convert units. But if you look at this, these are conversion of single unit. Meter and meter. Only prefix is the one different. And then this one is millimeter to meter. Right? These are straightforward, one type of conversion. Now, the next one is more than one type of physical quantity. Okay, that is our next one. Okay, so example 3. Example 3, density, rho. Density for, let's say, copper is 8,970 kilogram per cubic meter. Okay, you see 2 units now, kilogram and meter. So change this one to gram per cubic centimeter. Okay, becomes smaller. Then make it smaller. So first step, split these two. 8970, and that one is our unit, kilogram per cubic centimeter, per cubic meter. And then we put it like this. The negative we move down, so now we have power 3, right? Now we can convert one by one. Kilogram, you need to change to gram. Well, kilogram change to gram is 1000 gram. Okay, and then here, cubic meter, remember that? That is cubic meter, yeah? This is square meter. You change, you become 100 centimeter. Okay, so this one will be 100 centimeter power 3 outside. Okay, and after that, take the number out, 8970. The number here is 1000 divided by 100, but don't forget the power 3. And the unit follows. Okay, the unit will be here. So our unit is gram per centimeter cube. Okay, and then the rest will be just number. So this one will become 1000 divided by 1 million. So you're going to have 1 over 1000. So now this unit can be changed to this format, which is the format they want. And then this one divided by 1000 at 0.970 gram per cubic centimeter. Alright? So these are examples of more complicated conversion of units. The procedure are all the same. You just need 2 things. How to convert the prefix. First one you see normally involve prefixes. Okay, all the prefixes, how to change them. Power 3, right? Kilogram. Then here is also the same prefixes. Okay. This one also prefixes. How do you convert the prefixes into real number? Okay. So these are example of conversion of units. Now I give you one exercise here. Exercise 1. Okay, exercise 1. Convert the following units. Okay, A, meter, kilometer per hour to meter per second. And then B, okay, and then B will be gram per cubic centimeter to kilogram per cubic meter. The opposite of example number 3, you can refer to this one. And then number C, okay, can't think of any example anymore. So number C will be, let's say, I think enough, 2 enough. Okay, 2 enough. Alright, so you have exercise 1 and also assignment 1. Alright, so that's it for chapter number 1. You have covered units, base quantity, derived quantity, prefixes, and also conversion of units. Alright, wait for the long exercise. Okay, so have a nice day.